Hi students, welcome back to force and pressure lesson. First video we have seen what is force and all. So today we are going to focus only on pressure. So what is pressure? The pressure can be defined as the force which is applied on unit area of an object. So if you are applying some force on an object, what is the area on which you are applying that force? That is called as pressure. So pressure can be defined like this and can be written by this formula. Pressure is equal to force applied on unit area. So pressure is equal to force by area. So what is the unit of force? Newton. 1 Newton. 1 N. Area meter square, or you can tell square meter. So what is the unit of pressure? Pascal. In short form, we can write P capital and A small letter. PA, Pascal. So PA is equal to 1 N by 1 square meter. So this is the formula we have to remember. So what is the relation of these terms with pressure? Once area is increasing, pressure is decreasing. Just opposite or reciprocal we can remember. So once area of an object is increasing, we need to apply only less pressure. Once more area is applied, less pressure. So just opposite. So pressure is directly proportional to force. How much force we are applying, that much pressure. So this is the formula. For example, if one force is given, okay, so the force is 100 Newton, area is 2 square meter. What is the pressure we need to apply? 100 Newton by 2 square meter, that is equal to 100 by 2, 50 Pascal. Like this we can apply this formula to find out the numerical problems. So in case of area, if you need to find out area, how can you find out area if pressure and force are given? Just take area up, pressure down. That is, area is equal to force by pressure. Like this you can just interchange the formulas and use in numericals. What are the applications of this? So I have written 3 examples. These are the applications. I'll just read and explain one by one. First one is, why school bags have wide straps? The school bags, if you notice, you can see the strap what is using to weight. Taking the weight. Here the strap is very wide. It is very wide. So the area is more. Here area is more means you need to apply only less pressure on your shoulder. Just opposite. Area is more, pressure is less. You need to apply only less pressure, less force to carry it. Second one is, why a sharp knife cuts better than a blunt knife? Blunt means not sharp. So here sharp knife. If the knife is sharp, this area, if it is very sharp, area is less. Area is less means opposite. Pressure is more. More pressure makes your cutting process easier. You can finish it very fast. Third one is, why the tip of a needle is sharp? Same like second one. If the tip of the needle is very sharp, area is less, the surface area is less means you need to apply more pressure. More pressure is helping you to stitch very fast. So these are the applications about pressure. So here next we'll see about the applications of this pressure. The pressure is exerted by liquids and gases and making the pressure on the walls of the container. So one by one we see now. Pressure exerted by liquids. This pressure depends on depth, walls of the container, bottom of the container. So the pressure is exerted by liquids depends on how depth the container is. And the pressure on the walls of the container, how the pressure is exerted at the bottom of the container. So by activity, I will show you how this is happening. The first one is depth. So always the pressure is exerted towards the bottom of the container. So once the container is having more water, from top direction to bottom, the pressure is increasing. So depth is increasing, the pressure is also increasing. So first one is depth. If we are taking one container or bottle with water and making holes at same depth in two opposite directions, you can see equal type of flow of water outside. That means here the pressure is same. What is the pressure exerted by this water molecules? It is same because the depth is same. Next is depth at different heights of the container. Here we are making holes in different heights. If this is marking 1, 2, 3, 4, you can make the difference. Once it is moving down towards more depth, the pressure is more. So because of high pressure, you can see the flow of water is straight because that much pressure is exerted by water molecules. Here 2 means some more straight but it is flowing down. There is a curve. 3rd means the pressure is less. 4th means it is least. So the main principle behind this is the pressure is increasing with the depth of the container. Next is pressure is exerted on the walls of the container. How can you prove this? So we can do one experiment. You are taking one container with water and we are inserting one hole and we are keeping one glass tube, and at the end of this glass tube one rubber material or some balloon you can keep which is not inflated. Once this pressure is exerted to this hole, what happened? It is making the balloon or rubber sheet inflated because the pressure is exerted on the walls of the container. Next one is at the bottom of the container, how the pressure is exerted. Here there is one activity. We are taking one transparent plastic pipe, filling with water at the end. Before filling water, we are placing one thin rubber sheet which was not inflated before. After filling water, we are waiting for some time because of the pressure which is moving towards the depth, making the thin rubber sheet inflated. So these are the activities we can remember to explain the concepts. Pressure exerted by liquids depends on depth, walls of the container and bottom of the container. Next we'll move to the last topic of this lesson, pressure exerted by gas molecules. That is called as atmospheric pressure. The pressure which is exerted by the air molecules on the surface of the earth, which extends around 300 km from the surface of the earth, above the surface. So this collision of the molecules is exerting some pressure that is called as atmospheric pressure. So this atmospheric pressure we can relate with blood pressure. So here what is the blood pressure of a person? 120 per 80 millimeter Hg. This is symbol for mercury level. So always you can relate with this blood pressure because I will explain how this is related. I am rubbing this to draw one diagram to show. So here atmospheric pressure is also a type of pressure, right? So that is also increasing towards depth. This is increasing, increases towards depth, and it is, here it is decreases towards top part. So for example, depth means you can remember here, you can just compare this. This is sea level or depth of the sea, and this is any high range areas or mountain, the topmost portion. What happened? Atmospheric pressure is decreasing once we go up. It is increasing towards, we are going down. So at the Earth's surface it will be the maximum. So what happens? How can you relate this with example of atmospheric pressure with blood pressure? A person who is a sea diver. Sea divers always will be swimming and reaching at the depth of the sea. So for them, if this is the person, here inside blood pressure is 120 per 80 millimeter. If they go up or down, this is 120 per 80, but outside pressure is higher than the inside blood pressure. If it is higher, what happens? It makes the body muscles to crush or making us crushed. Why? Because the outside pressure is higher than the inside blood pressure. So they have to take precautionary equipments to balance it. The next is, once we go mountains or any hill ranges, high altitude, what happens? Here it is, atmospheric pressure is less compared to blood pressure. So here a person is reaching, what happens? Here blood pressure is normal and outside pressure is very less. So that is the reason for some persons will be getting nose bleeding. So the person will be getting bleeding, nose bleeding, because blood pressure inside it is more than the outside pressure. That is the reason for nose bleeding. So we have to take the required precautionary measures to avoid these circumstances. So this is about atmospheric pressure. You can do one activity also. You're taking one tumbler with full of water, and you are inserting that tumbler to your palm, which contains one thin sheet of cardboard. You're keeping one cardboard on your palm, taking one tumbler of water, you're just inserting without leaking the water. So it is full of water. So what happens? This water molecule is exerting some pressure downwards. And on your palm, there will be some atmospheric pressure created by the air molecules. So here we have some atmospheric pressure. This pressure is more than the pressure exerted by the water molecules. So after some time, slowly you just remove your palm and just to try, you can see this cardboard is attached to this glass and there is no leakage of water. this attachment is because of the atmospheric pressure which is exerting upwards. So by this we are going to wind up this topic, pressure. Hope you understood this video. Bye.